All right, my name's Adam Coring. I worked with Mark at Plexus before the company was dissolved. We were doing a little bit of Elixir, working on a terminal application. That's where I got most of my Elixir experience. Right now I'm working for a company called Stack. We're not doing Elixir, but this was a side project that I did to kind of start to get back into Elixir. So this project is a long-range wireless deer cam. It's named Slay the Wild. It consists of two different components. The first component's the wilderness cam that you see here. This is hardware that's running with an Arduino board. It's a C application, and it's sending messages to a back-end server, which I have running on my laptop, and the server side is the Elixir component. That's called Basecamp, and that has the receiving radio that receives these images that are sent from the camera. The problems I was trying to solve with this application was I wanted to eliminate the onboard storage with typical trail cams. Most trail cameras, they take pictures, they store them on an SD card. You have to walk up to the trail cam, typically open it up, take the SD card out, load it onto your phone, load it onto a laptop back at the house, and every time you go out to where your camera's set up, you're leaving a scent. So I wanted something that was manageable, that you could manage remotely without having to actually go out in the woods and tamper with this thing. I wanted real-time images to be able to show up, whether I was at the property where you hunt or whether you're remote, still be able to get these notifications and see what's out there. Start trending these images, so they have timestamps right now of when the image was taken, but I'd like to start seeing if there's certain patterns, like certain times during the day that something shows up at a camera, certain days during the week, and being able to have that in Elixir, I can start to automate some of that by knowing when the image was taken. And right now, a lot of the boards that I've researched, they operate off the cellular plans, the long-range wireless boards. And so typically if you're out in a rural area, you're not going to have a cellular service, so it becomes problematic, and every camera that you purchase would have to have a cellular data plan, which is something that I didn't want to have to do. I wanted something that was operating off of a local private network, but still had the benefit of transmitting wireless signals long range that you wouldn't get from your typical Wi-Fi network. So the hardware I used for this application, the Wilderness Cam, I purchased a Link Spirit JPEG color camera. This operates off of a serial UART connection. There's 4 pins on this board. There's power, ground, RX, and TX to send and receive data. You can configure this camera, configure different compression rates for it. You can change the image size. There's even a power saving mode, so you can configure this thing to basically turn itself off and go into a low power mode to conserve battery. And it has 6 infrared LEDs with a photocell, so when the light changes from day to night, those infrared LEDs automatically kick on, and it allows you to take some night shots with the camera. I'm using a passive infrared sensor. It has 2 potentiometers, one to control sensitivity and another one to control timing. So you can control how sensitive it is, and then also how long in between it's gathering motion, so that way you can control how many images you're taking during a certain duration. The RF chips I'm using are the XB Pro model ZigBee Series 2. With these chips, you can set them up in what's called a mesh network, and you configure these chips to play different roles. So there's 3 roles within a mesh network for these chips. You configure a coordinator, which is what I have here connected to the laptop. This would be responsible for basically sending out messages, receiving messages to all the other RF chips that are within the network. And you have your end devices, which is what's connected at the top of this pole. And that basically just sends messages back to the coordinator and then receives messages from the coordinator. And with line of sight on these chips, they can have a range up to 2 miles if they can see one another. So the idea with this setup was, this is the demo setup, but I would have these 5-foot pole sections, and I could raise this thing up 20, 40 feet up in the air and basically point that down range wherever the receiver is to be able to pick up these signals without having the trees interfere with where I'm broadcasting. And if 2 miles isn't, if you need more than 2 miles, or you find that there's interference within that 2 miles and you just can't quite get that line of sight, you can set up what's called router devices, and they're the exact same chip, they're just configured differently. And the router just bridges the coordinators and the end devices, so it basically adds an extra hop in this network, so you can potentially span this thing out over 2 miles or give yourself a little bit more range if you have interference with setting up multiple routers within the network. The microcontroller that's running on here is an Adafruit Pro Trinket board. This is basically the same thing as what's in our Arduino Uno. It's the same Atmega 328 chip. It's just a smaller form factor board. You have the same pinouts. I like this board because it fits in the case really easily. I started out with an Uno and it was too big for this project, so I ended up getting this Pro Trinket board. It worked out a lot better. And what's nice about this board is it has an interrupt pin on pin 3. And so you can put this thing into a power saving mode, just like the camera board, make it go to sleep. And then the motion detector is wired into pin 3. When it detects motion, it wakes up the board, and then it takes the picture and then sends it over the radio and then goes back to sleep to save on the battery, because it's only running off of 4 AA batteries. When I first started this thing out, I started on a breadboard, so you can kind of see there on the top left. I have everything just wired directly from the breadboard into an Arduino Uno. And this was really just kind of a proof of concept. I wanted to prove that I could get all these hardware components to talk to one another and then have an Elixir application that could just a really dumb app that could receive the image and write at the disk. And that's what I was going for phase 1. And I achieved that with the breadboard. And then the Elixir app proved the technology out. And then I started to move away from the Uno to the Pro Trinket because of the smaller form factor. And I started to put together a case, which you can kind of see on the right. It's basically the setup here. I have the plastic box with the motion detector and the camera on it. And one of the problems I ran into early on was the motion detector can't actually detect motion through the clear plastic. So I ended up having to drill a hole through there and silicone it up to waterproof it. And the issue with the camera being inside the case was during the night shots, you get glare with the infrared LEDs coming off of the case. So at the bottom there, you can see that there's 3 lights that are just reflecting off of that. So I ended up drilling that one through as well, and then just putting some silicone in there to seal that up. And the image with the fan is a much cleaner night shot now that that's through the actual case. And then finally, I moved from the breadboard to a Perma Proto board. It's kind of permanent prototype board. So it looks like a breadboard, and it has solder pads on it. So you can actually solder wire directly to this board without having a breadboard sitting inside the case. And it has the same power ground strips that a typical breadboard would. You get all the benefits of a breadboard, it's just solderable. And at this point, I started to play around with how I was going to connect the actual radio, because I wanted the camera to be close to the ground so it could take the pictures just kind of eye level. But then if you're out in the woods, you're going to have trees surrounding you. So if the radio is in that box, it's going to be hard to kind of get that signal out. And so that's when I came up with this design with the Ethernet wire going through this pipe. And I ended up finding just female Ethernet jacks. It just has the typical 8 pins that you would find on a normal Ethernet connection. And I'm only using 4 of those. I just need power ground, RxTX. And I soldered wire to those pins and then ran those into the radio. And so at the top of the pole is the transmitter radio. And that just has the 4 pins that I need connected right to that Ethernet port. The Ethernet cable runs through it, comes out into the box. And then that allows me to have the microcontroller send a signal over that wire, which Ethernet's nice because it also adds an additional layer of shielding. It's twisted pair. So if this thing's going to be going up 20, 40 feet, I don't think USB would have cut that. So Ethernet gives me that shielding benefit, which was nice. And like I said, this is running off of 4 AA batteries in the box. And then it's kind of hard to see from the picture, but there's 2 little white jumpers kind of to the right on the bottom of the microcontroller on the board. And those act as hardware feature toggles. And so what I wanted to do is have these test programs on the board. The main program on the board is responsible for detecting motion, taking the picture, sending it. I also wanted to have other programs that I could run while I was setting this thing up, so I could calibrate the motion detector and so I could make sure that I had visibility to the coordinator chip. So these jumper pins, like I said, they're hardware feature toggles, so when you move them from a low voltage to a high voltage and then reboot the board, it'll load another program within the Arduino and basically set it up so you can tune in your motion detector, or the other one will basically receive ping packets from this transmitter, and when it receives a message, it just lights up the LED that's in there, so you can just visually see that, okay, I know that this transmitter is talking to the receiver board, and I have that line of sight without having to take a laptop out with you and look at logs and that sort of thing. Performance tuning was another thing I looked at. Originally, the time it took to actually capture an image, to the time it was received by the Elixir app and written to disk, it was taking over 2 minutes, which was just kind of too long. And I saw a lot of just poor image quality. You can see the bottom third of this image, it's kind of chopped off. And when I looked at this, I was using sample code that was provided with the actual camera. This was just C code, example Arduino code that they put out there to get you going. I found some issues with it. They were using a delay, a 25 millisecond delay in between iterations, which added time, obviously, to the total time it takes to process the image. And then they were using a buffer size of 32 bytes, which is kind of one of the limitations on these boards. You don't have much internal memory. So when you read an image from the camera to the board, you can't read the entire image in one pass. You have to read it in chunks. And so you read a certain segment of the image, buffer it, and then you write that out on the radio, and then you read another section of the image, buffer that, put it in the radio. And so I was able to increase the buffer size from 32 bytes to 1024, which also helped speed this up. And so I just had some sample code there with the new algorithm that didn't have the delays within it, and then you can see it reduced the time from 2 minutes to about 16 seconds, and the image quality is a lot nicer. You don't have the choppiness on the bottom of the image. So where I want to take the hardware next is I want to add a Adafruit Music Maker shield. This is a shield for an Arduino, and you can put MP3s on here, and there's speakers hooked up to it. And the idea would be to use this as a call, so you could have it play different animal sounds, and you could control this from your Android device. So the Android device would have a radio that it's talking to, another one of these radios, basically joining the mesh network and then talking to these boards and telling it what different sounds to play and which cameras should play that sound. And then I want to start looking at adding some graphs to the Elixir app to trend these images, do some image recognition, and potentially send out notifications when the batteries are starting to run low. So I'm going to jump into the Elixir app next. Like I said, this is Elixir. This is running with Nerves UART. So I basically have a process that's constantly monitoring for data to come in on this radio. And when an image comes in, it'll write it to disk, and then it will send a message across a pub sub channel. I'm using Phoenix. So the browser actually has a WebSocket open, and when a message comes in, the image is written out, and a message is put on the WebSocket, and that tells the browser that it needs to go and download the latest image and refresh the page. And it's just hitting the Phoenix controllers to basically say, with this image ID, give me the image bytes back. And at the bottom, you can see I have a little image gallery, so you can click next, previous, and cycle through these images, and that's also hitting that Phoenix controller. And I added just a QR code generator, so if you're looking at this not on your laptop, you could take your phone, scan the QR code, and get the URL for the image and download it, share it, do whatever. And then I also put in, within this, I have a notification service in Elixir that's publishing to the WebSocket. It's also publishing Android push notifications. So if you're not sitting in front of a laptop and you don't have that WebSocket connection open, the Android push notification will send it to your phone. It'll send you a link, and you can click the link and then see the image. And then I found a Quantum, which is basically like cron for Elixir, and I'm using this as a scheduler that just runs once a day at midnight, and it goes through and it just purges any image that's older than 30 days, so that way I don't have to worry about it's not a database, but worry about the file system filling up with these images. It just purges itself over time. So I'm going to share some code here. So on the Elixir side, my application, I have the Phoenix endpoint configured, and this Phoenix endpoint has a user socket, which just has one image. It's just one channel right now. It's just the image channel. So when a user joins this channel, what it does is it publishes the last known image that was taken across the channel, and that shows up on the web browser. And then within the router here, I have endpoints set up to retrieve the first image that was taken, the previous, the next. So these are just different routes. When you click on the buttons, it just basically retrieves, it figures out what the ID is of that next and previous image, and then it gives you a URL that you can render that in the browser with.
Bump the code. It looks fine from here, but I think on the stream it's probably going to be a little small.
Let's see here.
Sorry.
not sure how to do that.
Sorry. It's okay, I guess.
Okay. The next process here is the actual UART server. This is using the NERV's UART library. What this does is I have a vendor ID configured for these RF devices, 1027, and basically it'll just auto scan. So when this thing starts up, it's going to enumerate over all the ports. It's going to look for that vendor ID, and if it finds one, it's going to automatically connect to it. And when it connects, it opens up a connection, and I spin up an async process. And the reason I'm doing this outside of the gen server is because I want to have the ability to have a process that's just constantly reading with that PID, and then eventually add in a way to be able to publish a message to the gen server and have the gen server's keeping state of the PID. So I want to have a write message separate from that async process come in and be able to write that out over the radio. So that way if you wanted to request an image or send a message from the coordinator to the end device, you could do that, and this async thread will still be running in the background. It's just reading all the time. And so anytime it reads data, it times out after 5 seconds, but assuming that it does read something, the first thing it does is reverse the bytes. And I do this because in a JPEG image, your start bytes are your FFD8, and then your end 2 bytes are FFD9. And so by reversing them, I can use a binary pattern match on this handler, and the FFD9 reverse is D9FF. So whenever I get a packet that has that D9FF as the first set of bytes after it was reversed, I know I'm done reading the image. So I take everything I've read so far into the buffer, I write that out the disk, and then I tell my notification server to send out a message. And the notification server is responsible for sending out a broadcast on the WebSocket. So any browsers that are connected, they can get the latest image. And then it also has support to do Android push notifications. And it's really simple. It's just using Firebase. And with Firebase, you're basically just Google gives you a URL that you publish a message to. And you can define in that payload a title, the message, a URL, and you give it a list of device IDs that you want it to send the message to. And I have a server that I have all this stuff configured on, so I'm really just publishing to my server, and then my server knows how to integrate with the FCM to do that push notification. So all my devices and email addresses, text messages, those all exist one place on a server, and that's where the Firebase integration lives. And then the last piece is just that scheduler. So this is just a quantum scheduler, and you have a config file. So this is just set up. Like I said, it's just a cron. It gives you a cron interface, and I set this thing up to run once a day at midnight, and you just tell it what function to call. Going out the disk, taking today, subtracting 30 days, and then I'm just looking at each one of the files, I'm looking at the ISO extended timestamp, and if that's before that 30 days, then it's an old image, so I'm going to go ahead and purge it. So a demo here, this has been going, so you can see this one was last taken at 11:33.
Those guys look like deer in the headlights.
So the image gallery allows you to just kind of cycle through. That one was a miss, I guess. And some of these I still haven't quite worked out all of it. It's gotten better, but obviously some of these have some corruption on them. And then if you click on an image, it'll flip to that QR code so you can quickly download the image. And then I was going to demo the push notification. So on my phone, I have an Android app running, and the Android app basically is just listening for messages, typical Firebase implementation. And when a message comes in, it'll give me a little pop-up notification, and with that pop-up notification, I should be able to view the image. All right, so I should now be receiving notifications. Like I said, it takes about 16 seconds right now to send that, write it out. And then the publishing happens pretty much instantly.
My God, it's coming right for us!
So there's any South Park fans. So you just get a little pop-up notification, image captured, and then I can click on that. And I got to be on the Wi-Fi, but I got to be on the same network as the laptop right now because this isn't hosted over the internet. But if I connect to the Wi-Fi, I'd be able to view the image that you see there. So, any questions?
Pass the mic for questions. So, is it on, Ben, or do I need to? Did you turn that on? Nope.
We're not that big of a group, are we?
Well, I mean, the internet's a big place.
So my first question is, I've tried to integrate with Firebase before, and some of the libraries at the time weren't quite there. I was wondering if you used a hex package or did you end up rolling your own?
The Elixir integration,
Yeah.
I ended up just using Poison. So it's just a raw HTTP post. And
Gotcha.
then you give it a list of device IDs. There's an API key that you have to give it, and then just a JSON payload.
Yeah, okay. That's what I ended up doing too. There used to be some libraries. I didn't know if any of them finally were updated, so that's cool. Does anybody else have any questions?
Testing, testing. I have just a quick question on the push notifications. I think I've worked with them maybe a couple years ago. When I did, it was a very kind of fragmented situation. Like, you know, Apple had their API, and then on Android, if I remember, I don't think we never got to the point where actually fulfilled the Android part, but I remember basically Android was a kind of a lot of third-party libraries. So just wondering what you chose for that, and if that was still like kind of an issue where you kind of maybe had to accommodate a lot of different libraries or frameworks or something like that.
On the Android side, it was pretty straightforward. I came from, I was doing push notifications a while back when it was the Google Cloud messaging service, and that one was very difficult to integrate with, to say the least. There was a lot of code that you had to write on the Android side. The publishing to it on the client side was pretty simple. It was just another post, but there was a lot of work on the Android side to do that. And then when they switched over to Firebase, it's a whole lot simpler. So I mean, there's only a few interfaces that I had to implement on the Android side. It's really straightforward, and it's, again, the client's the same. You can just do the HTTP post and the message get routed.
Okay.
All right, I have another one. Have you tested battery life? And if have you thought about doing like solar charging of the battery?
Yeah, solar charging would probably be an option. I guess the challenge there would be like you're in a wooded area, so just even kind of getting sunlight down where the camera would be for the board would be probably challenging. I'd have to put it up the pole like this and then run another cable down to charge it. It's certainly an option there to look at. This is actually the original set of batteries, so I haven't run this thing overnight or anything. There's a switch on the battery pack that I turn on when I want to test with it. I'd say there's probably about 24 hours at least on the batteries right now, and yeah, I'm just going to keep running them until they die, and we'll see how long it lasts.
Nice. So another thought, if you attach speakers to that and get that working, it would be perfect for a haunted trail, right? Yeah. Like you just set them up along the trail, kids like run through and play all kinds of spooky noises. It'd be cool.
Yeah, I was thinking about a separate box for that because there's really not a lot of room to put it in that one, and it's just going to drain the batteries to have speakers playing on there as well. So I was thinking separate box, separate radio, and just have it hooked up right next to it.
Sweet.
It's got to upgrade to D cells.
Yeah.
Yeah. There you go. There you go. You're using Nerves UART. Have you tried? I noticed you're using passive mode. Mm-hmm. When I've used it in the past, I've kind of experimented with active versus passive. It seems like active might be good here. Have you tried that?
I haven't tried active. I'm trying to think why I was using the passive. With the passive, I'm doing multiple reads and buffering the image. I guess in active mode, I would have to publish those out somewhere and store the buffer internally, so it seems like
Yeah.
it'd be doable, but the passive was just really simple enough to just continuously do the reads, buffer the image, and then when you read the last bytes, write it out and clear the buffer.
Cool. Anybody else? All right. Well, thank you very much. It was really awesome.
All right, thank you.
Have you thought about open sourcing it, or is this something that you want to take further than? All right. So this is usually the part where we go more into like demos and kind of hands-on sort of things. So I think Mark said he might have something he'd want to show. Did anybody else have a demo that they wanted to walk through? All right, Mark, if you're still up for it. Yeah, it's weird. There's been some moves there lately. Huh? Yeah.
Yeah, you wanna turn off the internet for this part of it? Turn off the stream again. I'll turn off the internet.
Yeah, please turn off the entire internet.
There's a switch back there?
Yeah, it's really cool. No.